What's up, everybody? Welcome back to the channel. Got another DeLorean video for you guys today. It's been about 2 weeks since the last time I made a video on this car. Martin and Steve have both been working on it a bunch and made really good progress on the car. But I don't want to make a video on absolutely everything that we're doing because, a lot of it is similar to the last car. It's the same car, same power plant. But I did promise in the last video that we were going to be showing you guys some of the CNC parts that we made for the car, which is actually good because that is one of the parts that we changed quite a bit. Every part has been redesigned a little bit to try and improve and make the car better. So I'm going to take you guys back about a month and be showing you guys the intake manifold that we made for this car and some of the changes that have been made to that. So let's get right to it.
When we were asked to build a second DeLorean, quite a few of the parts were changed because we had gained a certain amount of experience building the first DeLorean. And the second DeLorean decided to take advantage of that, and we made the bottom and the top part of the manifold a little bit taller. It's actually about a full 1.5 inches taller. And I can go ahead and make this transparent. And one of the things that allowed us to do is each one of these is now taller and a different length. I made this one slightly shorter, this one's longer, and then this one is quite a bit longer. And so what that does is that gives us a broad range of resonant tuning so that these two cylinders, and these two cylinders each have their own resonant frequency that they will be the best at. This and the manifold being made taller also increases the volume, the overall volume, the inside of the plenum, up to where it's actually really good, even for a naturally aspirated application. So I believe at the top end of the RPM range, we probably will get a bump of like 5 to 6, maybe even 7 horsepower at the same boost pressure over the last engine. Like the last engine, we wanted to go ahead and pay homage to the DeLorean claim to fame, Back to the Future, and so this here is the date that they have to go to in the future from the movie. Anyway, and this throttle body is based on an Infiniti Q45, and I actually use some of the moving pieces that are from the original Q45. We buy those used and take them apart, but I really like it because it has double lip seals, it has ball bearings for the pivot, it has a stainless steel shaft, and you can see that the brass blade is actually pretty thick and beefy. So I don't really like the actual Q45 throttle body, so what we end up doing is making our own housing for it to go into. Given that the last car ended up making over 600 horsepower at the crank, the person that asked us to build this car went ahead and wanted me to put something on it to denote the horsepower. So we went ahead and at his request added this separate 600. Gone ahead already and started to set up all the pieces as far as machining them and doing all the tool paths. At this point, all my tool paths are done and ready to go, so I'm gonna go ahead and fire up the machine, and we're gonna make this.
operation done. We're going to flip this thing over and do the other op, which is the other side. And take the actual top piece of the intake plenum off. That way we can have that powder coated. We were able to use it to set up the intercooler end tank, so that is done now, and we can go ahead and get this powder coated.
Several days later.
So we've got the intake plenum top back from the powder coater. You guys can see this is the color we went with on this car. It is a navy blue. We kind of based it off of some old Maserati colors. There's a little bit of sparkle to it, which you guys will see in the sun in future videos. But I think it looks really good. It contrasts really well with the gold. If you guys remember, this logo here, the DMC logo, and these lines here will all be have the powder coating sanded off and have a nice contrasting silver, like similar to how you would see here or on this AN bung here. So that is the intake plenum. The blue and the 600 both make for a really cool visual change from the first car to this car. We're really stoked with the way that came out. That'll be interesting to see kind of like what the power differences are, once we get this car on the dyno with the changes that Steve made in the actual design. Of course, the intake plenum is just one part of a lot that Steve has made, from the custom flywheel to the brake setup, to the intercooler end tanks, all the way down to the AC system having custom machine fittings. But for the rest of this video, I kind of want to show you guys one of the biggest single changes we made on this car, which is actually the fueling system, specifically the surge tank, which has been completely redesigned from the last car to this one. So let's get right into it.
All right, so this is going to be the top of our surge tank here. These holes are all going to be threaded, and this is a channel for an O-ring to be put into to seal the top lid that's going to hold the fuel pump. And then this here is going to sit onto the top of our can. So I'll go ahead and bring this into our surge tank assembly. So here you can see the bottom of the tank and the can of the tank. We'll go ahead and add the top. And I'll mate this here to this. And we'll flip it over. Okay, and we'll bring that out, and we can mate this surface here to that surface there. Alright, and so that's actually going to be what's needed for the actual tank. Now, there's going to be a top cover that goes on that'll have a support in it for our fuel pump. And this is our Hellcat 450 liter per hour fuel pump that we're going to be using. Anyway, that is going to sit in the bottom of this tank, and there's going to be basically a cover that supports it and has the power going through it. I will go ahead now and draw the last piece of the puzzle, which is our top. use the last piece in our surge tank. In this specific car, because of the flat nature and the way the tank is so far in front of the car, we decided that it was actually kind of important that we had a pretty big surge tank, and this specific engine uses a fair amount of fuel. So with the fuel sloshing around in the front of the tank, with the tank actually being kind of low, we decided we wanted about 1.25 gallons of fuel in the surge tank. So I'll go ahead and show you our assembly here. This is actually going to be the surge tank. And so I'm now going to go ahead and make this transparent so you guys can see the inside of it. So here at the bottom we have our 450 liter per hour Walbro made in USA fuel pump that's E85 compatible. I believe this is commonly referred to as a Hellcat pump. We already have made the bracket, and this uses a little piece of like a O-ring that is safe with both the 85 and normal fuel. Okay, and so this is going to kind of slide onto the pump here, and its main point for this is to keep the pump held upright. Now the filter itself has this cute little button, so the bottom of the filter will be able to sit directly on the bottom flat plane of our end cap. So it'll sit on that, and then this bracket here will keep the pump centered in the can and keep it upright. Now as far as getting the electricity in to power our pump, these are parts that I frequently use in a Ferrari design that I have made. It uses these two cute little bolts that are going to go through this piece, and will actually, one will carry positive and one will carry negative. And you can see those are up here at the top here. And so this has a combination of about, I think it's 12 O-rings total, that like triple seals each individual bolt, and has 4 seals. You can see there's 2 seal grooves here, and then there's 2 seal grooves. I'll make one of these invisible. And so you can see there's also going to be an O-ring groove there on the top and the bottom. So for it to leak, it literally will have to leak through 4 O-rings. Alright, so then this here is going to basically be an NPT fitting that's just going to be a barb fitting. It's the same as the one that's on the pump, and we're going to use the little plastic accordion style hose that comes with the pump to put the fuel from here to there. That's going to be our outlet. Then you can see this one here has a cavity and is up high. That's going to be our return back to the pump, back to the tank that's in the front of the car. And then basically this piece here, you can see, has 9 blind female holes that are going to be threaded. The top cap will be bolted on and off so that we can work on the pump and do whatever we want to do inside the tank. This piece is going to be welded onto our actual extruded can, and I think that's basically everything that you guys need to know about the surge tank. It has 4 -6 AN fittings. This is going to be pressure to the regulator and to the injectors. This will be returned from our E85 sensor and the regulator. This will be feed in from the tank, and this will be returned to the tank. Right, so now that I went over with you the actual full design of the surge tank when it's completed, now what we have to do is I have these pieces here of pre-cut 6-inch. What was that? We're going to go ahead and make each one of these individual pieces. So you can see here, we need to make this piece, which is our top cap. Then we need to make this piece, which is the top nut. And then we need to make this piece here. So we bought pre-cut 6-inch round pieces, and I'm going to go ahead and put these into an assembly with the part and go ahead and do the tool pathing to machine these individual pieces. After we designed our part, put it in our stock in an assembly, I went ahead and did all the tool pathing. Now, the next process in this is that we're actually going to do a simulation. And you can see there, that's a simulation of the actual machining process. And I will do that one more time and slow it down. Okay, and that simulates all the tools and all the tool paths that I've set up. This is to do one side of the machine. Now what I'm going to do is we're going to go down here and we're going to list these tools, which I've put here, and those tools are already all loaded in the machine and set up. So what we're going to do is we're going to go set the heights of the tools to our stock and load our G-code program, and we'll run it. Alright, our part is finished with the first operation, and what we're going to do now is flip it over and do the other side. Now, to orient it, I made a cute little line in it with our bandsaw, and all I have to do is line this line up with the other side of the fixture over here. So in this operation, it was between there and there, which puts this in the center. Now I'm going to flip it over and center it in the gap on the other side of the fixture, and that'll again put this hole in the same place, and we will machine it without having to make an elaborate soft jaw to index these screws absolutely perfectly.
Had a little bit of a warped tubing situation, but we got it on. Seems to be good. Again, same as this side. This is going to be welded here, just like he said. And then once we've got the cap on, that gets bolted to these holes.
Alright, so we have our top end and our bottom on the can now. Martin will go ahead and weld these together. Before he welds them together though, I am going to go ahead and make the next part, which will actually be the last part for this assembly, and that is our lid. And I already did the entire machining profile for the lid. This is our stock, and those are all the necessary tool profiles. So I'm going to go ahead and get this piece set up in the machine, and we'll start with operation 1. Alright, our part is done being machined, and I'm going to go ahead and test our -6 fittings to make sure that the threads are good. One.
Works beautifully.
This one goes here.
Also works beautifully.
Okay. This one goes here. And finally, this one goes here. Okay, and now that we tested our AN fittings, I'm going to go ahead and make sure that the plastic for the power distribution. So the way it works is negative goes through one bolt and the positive goes through the other, and seals with multiple O-rings. So this piece should like kind of be a little bit snug when it goes in, and you can see it doesn't move or wiggle. You push it down and you can definitely feel it's a touch snug. This completes this part of this project on my end. At this point, now I'm going to give this to Martin, and Martin will figure out how to mount it in the car. There's one other little piece of this that's over here. When this is put in the car, to stop these from being shorted out, I have this cute little boot that's going to go right there. We'll probably mount it like that or whatever, and make a little loop to hold it to one of the screws. Anyway, most of the CNC parts in this car are like this project, in that in the beginning we realized that we need something specific, and in this case we needed a larger surge tank because of the location of the tank and the poor design of the original factory tank. We needed a larger surge tank than was readily available. So we went ahead and made this. Most of the other things in the car that are CNC machined are exactly the same scenario as this, where we need something, I'll design what I want to make, I'll show it to Martin, the two of us will talk about it. We might make a couple changes after the two of us discuss the design that I'm suggesting, and then I'll go ahead and you know, set it up, program it, put it in the machines, and make it. In most cases we have the parts anodized and we pick the colors, but in this case we're going to leave this part raw.
So it's been about a week since you guys have seen the surge tank. I went and ran a couple of errands, drove off to Colorado. You guys will see some of that in the future. While I was busy, Martin has been working on the surge tank and getting all the exterior stuff ready to get the thing put into the car. So I'm going to let him kind of explain the things he's done and why he's done it. So let's get to it.
So as you guys can see, this is our fuel surge tank. Basically, last time we built the same exact car, we built something similar to this, but Ferrari Steve went ahead and decided to design a top and a bottom cap out of CNC machining. So it'll be much stronger and nicer quality of finish. And of course, this will allow us to make the in-tank fuel pump within the tank. And you know, he made all these custom electrodes, plungs for it and everything. So like I said, this is a much better quality than the last one we made. But we kind of had a similar system, but this time we went ahead and decided to mount pretty much everything within this tank. That way we don't clutter our engine bay. So as you guys can see, I had to fabricate a bracket to hold this E85 sensor, fuel pressure regulator, and the fuel filter right before you go back in to the fuel rail. So it came out pretty slim, and now I can show you guys how it fits in the car. So basically, just goes in like that. And I have these mounting brackets that I also made. This will be bolted onto here and like that.
There we go. Looks good, and like Martin said, it's really nice to have all of this kind of contained in this pontoon here. You know, that way if you ever need to work on the fuel system, all the fuel will just leak down into the bottom of that.
You guys remember this? So most of it
gets
will be
covered
covered up, and
Kinda
we'll have
keeps-
one single fuel line coming from here into the fuel rail, and that's it.
So not only is it cleaner, but it's also, you know, a bit safer to work on and have everything, you know, contained and blocked off by this plate. Keep all your fuel separated from the rest of the engine, so that's nice. And go ahead and get this thing installed and hopefully get it lined up to the rest of the tank.